In this video, we will look at how to use the AM FM Demodulator block with the Spectran V6 analyzer. On screen, you can see a small sample mission created in the block graph editor. We start with a calibration block that includes the antenna, any amplifiers, and cable losses. This block feeds the calibrated RF signal into the Spectran V6 analyzer. The V6 then provides an IQ stream, which is converted into spectrum information by the IQ power spectrum block. That spectrum information is then available to the AM FM demodulator and to other display blocks that you might want to use in parallel. Let's begin by configuring the calibration block. In the block graph editor, you can type the name of a mission or block to add it to the setup, but here the mission is already built. Locate the Calibration tab and double-click it to open the configuration. In this example, the setup uses a 6 GHz omnidirectional antenna. The frequency range of interest for this demo is around 90 MHz, which is below the optimal range of this antenna, but still acceptable. In the response graph, you can see that the antenna is defined down to about 150 MHz. This means there is no severe roll-off yet at 100 MHz for these particular measurements. All Aaronia antennas are predefined here, so you can easily recall them from the list. There is a separate video that goes into the calibration block in more detail. Next, configure the Spectran V6. Locate the Spectran V6 Eco tab. In this mission, a GPS signal is used to improve frequency accuracy. The GPS mode is set to location and time. If you scroll down to Position Config, you can see that real-time position updates provide location, latitude, longitude, and elevation information for documenting the measurement. There are dedicated videos that cover the GPS and position configuration more thoroughly. The signal path then continues into the IQ Power Spectrum block. Find the IQ Power Spectrum tab and double-click it to open its settings. For audio-focused measurements, the FFT size is set to 4096. You can change this value, but 4096 is a good starting point for audio analysis. Overlap mode is enabled with about 70% overlap. For the FFT window, the hand window is selected, which is well suited for audio type measurements. There is a separate video that explains the IQ Power Spectrum block in detail, but for AM and FM work, these three settings, FFT size, overlap, and window, are the most important. Now, we move to the AM FM Demodulator block. Click the Grid Editor button, the green pencil icon in the ribbon bar, to return to the block graph editor and gain more workspace. Adjust the window sizes so the AM FM Demodulator block and its displays are easier to see. Double-click the AM FM Demodulator block to open its configuration menu. Depending on your setup, an audio sample rate of around 22 kHz is sufficient for this demonstration. Here, we are using an FM signal, as indicated by the frequency range displayed. The center frequency changes as you move the cursor, allowing you to select different channels. The channel bandwidth is set to 240 kHz, but you can narrow it when you want to focus on a specific audio signal. Now, start the measurement. You will see that the information across the different spectrum views is almost identical. You can independently zoom in and out on the IQ Power Spectrum display. You can also zoom in and out on the AM FM Demodulator display to focus on specific signals. At the moment, a signal at about 73 MHz is being demodulated. Visually, it may look like an FM or AM FM signal, but it is not actually a standard broadcast FM channel. By adjusting the X and Y axes, you can change the resolution and see that it lies outside the typical FM broadcast band. If you slide the view to the right, you begin to see clear indications of FM broadcast channels. Moving the cursor onto one of these channels allows you to listen to its audio. These channels were defined by the user in the configuration and have been labeled as radio stations. The labels include the frequency and the channel bandwidth. You can easily jump to a different radio channel. Zoom in on the frequency of interest, then select that channel to demodulate it, or choose an adjacent one. The defined channels provide helpful feedback about which frequency you are currently observing. In this example, 3 channels are set up to provide streaming audio simultaneously. With 40 MHz of real-time bandwidth, the V6 can demodulate all AM and FM signals in that span in parallel. If you add more channels, such as a radio station at 94.3 MHz, it will also appear as a demodulatable audio channel. To listen, move the cursor to that radio station and turn on the speaker output. You can hear the signal being demodulated. Then move to the next defined channel and demodulate that station. When you are finished listening, turn the audio off again. You can freely jump between different signals and demodulate any of them according to your needs. To control the listening level, use the audio gain control in the AM FM Demodulator. This allows you to adjust the audio gain as needed for your measurements. For a more detailed view of the spectrum activity, you can switch to the waterfall block. The waterfall provides a time versus frequency view that makes it easier to visualize signal behavior. If you zoom in, you can clearly see which signals are FM modulated and distinguish them from non-FM carriers. You can also run the 3D waterfall block in parallel. This adds a 3-dimensional representation of channel appearance and amplitude over time. Use the X scale to zoom in on the frequency region of interest. Adjust the size and position of the 3D view to highlight the signals you want to study. This concludes the introduction to using the AM FM Demodulator block with the Spectran V6 Eco Spectrum Analyzer. For more information, check out our other videos on our YouTube page or visit AaroniaUSA.com.